First of all, big thank you to European Meteorological Society for the Young Scientist Award. And thank you to Estonian Meteorological Society for nominating me. Also, I would like to thank all the co-authors of this work, especially Nicolas Belouis from University of Reading. The title of my presentation today is Anthropogenic Aerosol Impacts on Clouds and Earth's Climate. One day 4 years ago, I was studying the impact of shipping emissions and volcanic emissions on clouds. I was asking myself a question that why I don't see such polluted cloud tracks over land. I realized that such true color satellite images, what are similar to what we see with our own eyes, are not optimal. So I need to use satellite measurements what are sensitive to cloud droplet size. And a few hours later, I had found many hundreds of such land-based industrial polluted cloud tracks. And I immediately realized that these polluted cloud tracks will help to better understand anthropogenic impacts on Earth's climate. What are aerosols? Aerosols are tiny solid and liquid air pollution particles that are harmful to human health but offset part of the greenhouse gas warming. And one of the main sources of anthropogenic aerosols is burning of fossil fuels. Aerosols interact with electromagnetic radiation directly. So here you can see wildfire smoke, and the smoke is bright compared to the underlying dark ocean. This is because smoke particles reflect solar radiation back to space. In addition, aerosol particles are necessary for cloud formation. And now if we add anthropogenic aerosols into atmosphere, the cloud water redistributes over a larger number of cloud droplets and clouds become brighter. Here you can see clouds impacted by shipping emissions as these bright lines. And my research is really about how much brighter do clouds become in response to anthropogenic air pollution particles. Here you can see effective radiative forcing of Earth's climate. So radiative forcing in watts per square meter measures the difference between energy received by the climate system from the sun and the energy given away by the climate system as thermal radiation to space. And now if Earth receives more energy than it gives away, the forcing is positive and Earth warms up. The total anthropogenic forcing is the sum of greenhouse gas warming here in red and aerosol cooling here in blue. The probability density function of greenhouse gas warming effect is rather narrow, meaning that greenhouse gas warming effect is very well quantified. But there's rather large uncertainty in the aerosol cooling effect, and really the aerosol cooling effect dominates the total uncertainty in the anthropogenic radiative forcing. If there's very strong aerosol cooling effect on the Earth's climate, here the temperature projection with the red line, then rapid future warming is expected, as this would mean that already observed warming is caused by a relatively weak positive forcing. And when there's no aerosol cooling effect on climate, here the temperature projection with the blue line, then much more moderate future warming is expected, as this would mean that already observed warming is caused by relatively strong positive forcing, and our climate is not that sensitive to anthropogenic forcing. So this here illustrates why it is very important to better quantify aerosol impacts on Earth's climate to more reliably predict the future climate. The main aim of my research is to better quantify the anthropogenic aerosol impacts on clouds. The question to you with this true-color MODIS satellite image is that do you notice brighter aerosol polluted cloud tracks here in this image? I assume the answer is no. Here you can see a similar MODIS satellite image, but here near-infrared channel is also used, what is sensitive to the size of cloud droplets. So this whitish line here is polluted cloud, and it has been polluted by aerosols originating from this industrial pollution hotspot here. And why these polluted cloud lines are super nice is because we can directly compare the properties of the polluted cloud to the properties of nearby unpolluted cloud here in brownish, yellowish colors. And this provides a means to give confident answers to questions like how much brighter do clouds become due to anthropogenic aerosols. Here's another example of polluted clouds. Here's Shanghai region in China, and here are polluted clouds over ocean. So these brighter clouds here have been polluted by aerosols originating from the Shanghai region. This is the main scientific finding thus far using polluted cloud tracks. As expected, the cloud droplets are smaller in polluted cloud tracks compared to the nearby unpolluted clouds. However, in contrast to what is assumed in many climate models, clouds are not thicker in response to anthropogenic aerosols on average. So on average, the thickness of clouds is rather similar between the polluted and unpolluted clouds. In summary, there's still a lot to discover using polluted cloud tracks. Thank you.